Hi guys, welcome back. Domain 4, Identity and Access Management. Chapter 4.2, given a scenario, install and configure identity and access services. So in this video, we will see LDAP, Kerberos, the listed topics we are going to see. So before we go to the topic, so let me explain that what is identity and access services, why it is important. Okay, so identity and access management, in short we call it IAM. IAM is a framework of business processes, policies and technology that facilitates the management of electronics or digital identities. With an IAM framework in place, information technology managers can control users' access to critical information within their organizations. Systems used for IAM include single sign-on systems, two-factor authentication, and then multi-factor authentications and privileged access management. So these technology also provide the ability to securely store identity and profile data, as well as data governance functions to ensure that only data that is necessary and relevant is shared. So why is IAM important? Business leaders and IT departments are under increased regulatory and organizational pressures to protect access to corporate resources. As a result, they can no longer rely on manual and error-prone process to assign and track user privilege. So IAM, which has ever increased list of features included like biometric, behavior analytics, and IEA artificial intelligence, is well suited to rigors of new security landscape. For example, IAM tight control of resource access in highly distributed and dynamic environment aligned with the industry transitions from firewall to zero trust models and with the security requirement of IoT. So let's go for the topic now. So directory. The directory service provide transparency to protocols and network topology, permitting user to access resource without having to be aware of physical location of the device. It is important components of the network operating systems and is central information repository for service delivery platforms. Like, so the bullet point here is repository of an organization network resource, and users most follow a hierarchical database format based on X.500 standard. Here, directory service manager the entries and data in the directory and enable access control and identity management. So, types: Microsoft Active Directory, one of the best example, and LDAP. So LDAP, lightweight directory access protocol. So standardized directory access protocol. A main purpose is to query the LDAP users database pad down X.500 based directories supported by most major vendors including Microsoft AD, OpenLDAP, hierarchical structures, as you can see. So LDAP provides access to directory service including those used by Microsoft Active Directory. So LDAP was created as a lightweight alternative to earlier implementation of the X.500 directories access control protocol and communicates on port 389. The main purpose of LDAP is to query user directories. It is widespread use influence many other directory systems, including the directory service markup language. In short, you can call it DSML, service and then service location protocol, in short SLP, and Microsoft Active Directory and secure LDAP variations. LDAP is used for queries, so the LDAP process is simple. The client sends an authentication request to LDAP servers. The server queries the database to determine whether the client can authentication. You can see also on the picture. So after authenticating, the client requests access to a resource. The server again queries a database to determine whether the client has permissions to access the request resources. In Microsoft environment, LDAP is used to read from and write to Active Directory. So by default, LDAP traffic is transmitted unsecured and is subjected to the listed the few listed. The three main important things: one is a buffer flow vulnerabilities can be used to enact arbitrary commands on the LDAP server. Second is format string vulnerabilities might result in unauthorized access to enact commands on the LDAP servers or impair its normal operation. Third is improperly formatted requests can be used to create an effective denial of DDoS attack against the LDAP servers, preventing it from responding to normal requests. So LDAP traffic can be made confidential and secure by using secure socket layer SSL or TLS technology. You can enable LDAP over SSL by installing properly formatted certificate from either Microsoft Certification Authority or non-Microsoft CA. You can also see in the next LDAP security. LDAP is vulnerable to snoopings and the encrypt communications using SSL TLS to secure LDAP transmissions. So certificate can validate authentication requests. LDAP v3 bind requests should use simple authentications on SASL, simple authentications and security layer. So on the right side you can see it's one of the best example for handshake, SSL TLS handshakes. So the first request SSL send client send the request, and then server send back SSL option the certificate, then client send the proof. So this is a certificate. So and then server send back the message digest, and then systematic key encrypted and the random message. So this is the very good example of SSL and TLS handshake in this topic. So the next topic, Kerberos. So asymmetric key authentication protocol. So Kerberos is primarily a UDP protocol, although it is falls back to TCP for large Kerberos tickets. Kerberos client sends UDP and TCP packet on port 88 and receive replies from the Kerberos servers. Port 88 is the standard port for Kerberos v5 for the KDC, and port 749 is used for the administrative server. Okay, in the authentications, in the Kerberos authentications, a client sends authentication details not to the target server, but to a key distributed center. So I would say the few thing. K5 before we go to the K5 topic. So the list of key distributed center, the client first conducts a certificate authority. The CA creates the certificate authority, the CA creates a timestamped sessions key with the limited durations, example by default 8 hours, using the client key and randomly generated a key that include the identifications of the target service. This information is sent back to the client in the form of the ticket granting ticket time. Okay, and then the client client submit the TGT to ticket granting server TGS. So this server generate a timestamped key generated with a service key and return both to client. Okay, so then client use its key to decrypt its ticket, contacts the server and offer the encrypted ticket to the service. Then the service uses its key to decrypt the ticket and verify the timestamp match, and the ticket remains valid. And then the service contact the KDC and receive a timestamp session keyed ticket that it returns to the client. Finally, the client decrypt the key ticket using this key when both agree that the other is the proper account and the key is within their valid lifetime communication is initiated. Okay, so the K5 uses mutual authentications between the request client and the supporting server through a KDC. So the KDC The process helps prevent man-in-the-middle attack, in which an unauthorized party intercepts communications between two systems and masquerades as the other systems. The unauthorized part might pass some data intact, modify other data, or insert entirely new set of value to accomplish the desired task. In mutual authentication, one system creates a challenge code based on the random number and then sends this code to the other system. The receiving system generates a response code using the original challenge code and create a challenge code of its own. It sends both back to the originating system. The originating system verifies the response code as a value and returns its own response to the second system generated from the challenge code written within the first response code. After the second system has verified its written response codes, it notifies its originating systems, both systems that consider themselves mutual authenticated. Okay, so the strength of Kerberos authentication comes from its time synchronized connections and use of registered client and service keys within the KDC. There also creates some drawbacks, such as need to use standard synchronized time base for all systems involved. Difficult arise if the KDC is unavailable or the cached client and service credential were accessed directly from the granting server. An important advantage of a timestamp credential is that they help prevent spoofing and relay attack. So Kerberos is more secure than NTLM because it is uses strong encryptions. Its implementation consumes less bandwidth, and Kerberos tickets support identity delegation. So this is the Kerberos authentication process. As I said before, so each time the user wishes to access some resource on the network, the user computer presence. So these all are the main point when we talk about the Kerberos authentication process, and then the picture also give you a clear idea about this. Okay. So, and then remote authentications deal in user service radius. Actually, two prominent security protocols used to control access in networks are radius, and then the second one is next slide, a terminal access controls system plus. So these two prominent, we're going to see one by one. First, the radius. IETF standard. It is an IETF standards and implemented by most of the major operating systems manufacturers. Uses UDP transport to centralized server, provide authentications and access control for network. So the the authentication deal in user service. The remote access control system provide authentication and access control within enterprise network using UDP transport to central network access server. In turn, this provides credential for client access to resource within external enterprise. Radius was originally developed for use in dial-up connectivity over telephony, and you might still find radius servers in large enterprise where logons must span resource located in multiple logon realms. A protected network segment might implement a VPN and RAS, remote access server gateway connection, to allow an authentication external service request to reach a protected server by communicating with the radius server. The request account must be provided its credential to radius servers, which the authorize the access request. Your radius server supports a variety of authentication methods, including PPP, PEAP, CHAP, Unix login authentication mechanism. We will talk about this PEAP, CHAP. So we will talk about the next slide. The radius service can forward authentications and authorization requests between authentication domain control, and thus can facilitate cross enterprise authentication, often as a part of single sign-on SSO solution. So you can see also the picture, the radius server. So and in the enterprise, this is a simple picture for the enterprise. So how does it work in the enterprise environment? Okay, so the next slide, terminal access control system plus. So in short we can call it TACACS. I think so, yeah. TACACS is a protocol that was developed by Cisco and released as an open standard beginning in 1993. Although it derives from TACACS, and TACACS Plus is a separate protocol that handles authentication, authorizations, and accounting. AAA, what we discussed previous video. In the previous video you can check. So authentication, authorization, accounting services. So which means, so although it derives from TACACS, and TACACS Plus is a separate protocol that handles AAA services. TACACS is a smaller to radius but uses TCP as a transport method. It uses port 49 as the default port. TACACS Plus takes a client-server model approach. The client first queries the servers. This client is typically a router or firewall used to determine whether the user has proper authentication to access the network. The server sends back a reply stating whether the user passed authentications. So both TACACS Plus and Radius contain an accounting function. So if a device were intentionally compromised, an audit trail would show the originating IP address and the user account logged into the device. So TACACS Plus offer several advantages over Radius. There are four main things. I would say TACACS Plus tends to be more reliable because it uses TCP instead of UDP. Second is TACACS Plus encrypt the entire body of the packet in the original access request packet. Radius encrypt only the password, leaving information such as the username subject to the compromise. So TACACS Plus uses the AAA architecture. These allow the use of TACACS Plus for authorizations and accounting with the separate authentications methods. Radius combines that authorizations features of a AAA, so making it difficult to use the functions separately. Then last one, the fourth, is a TACACS Plus provides a method to control the authorizations of router commands. Radius is not as useful for router management or as flexible for terminal service because it doesn't allow user to control the command that can be executed. Okay. So consider an example of TACACS Plus should be used instead of Radius, and organizations require the use of Kerberos authentications but also need authorizations and accounting functions. In this instance, the network access server NAS, in short NAS, inform the TACACS servers that it has successfully authenticated on a Kerberos servers. The server then provide the authorizations information without having to re-authenticate. So TACACS Plus servers should not be running other applications. To minimize the chance of compromise the entire user password or password database, proper access control lists should be implemented, and additional security steps such as using TCP wrapper should be taken to prevent the ability to connect to the TACACS Plus server in case an internal device is compromised. Okay, let's move on to the next slide. PEAP. PEAP is a password authentication protocols. A legacy user ID and password send clear text, so no protection for playback or trial and error attacks. So PEAP is a simple authentication protocol in which the user and password are sent to the remote access server in plain text form, as you can see in the picture. PEAP offers no protection from playback or trial and error attack, as I said before. So the remote server is in control of frequency and timing of the login attempts. Using PEAP is strongly discouraged because user passwords are easily readable from the PEAP package exchanged during the authentication process. So the default status of any PEAP link is not to require authentication of the remote host. PEAP is typically used only when connecting to older Unix-based remote access servers that do not support more secure authentication protocol. So let's move on next slide. CHAP. So CHAP, Challenge Handshake Authentication Protocol. It can be used to provide on-demand authentication with an ongoing data transmission. CHAP uses a one-way hashing function that first involves a service request, a CHAP response from the client. The client creates a hashed value that is derived using the message digest MD5 hash algorithm and sends this value to service, which also calculated the expected value itself. The server referred to as authenticator compare the two values. If they match, the transmission continues. This process is repeated at random interval during a session of data transactions to help eliminate the possibility of a reply attack. The process of authenticating is called three-way process. You can see on the example picture. Actually, 4 steps are involved because the first step is establish the connections, but the authentication process itself is a three-way process. CHAP is improvement over PEAP because it hashes the password but still sends the username is in clear text. CHAP functions over point-to-point protocol connections. PPP is a protocol for communicating between 2 points using a serial interface, providing service at second layer of the OSI model, the data link layer. Okay. So let's move on next slide. MSCHAP and PEAP. So it's a Microsoft CHAP is encrypted authentication mechanism that is similar to CHAP. It comes in 2 versions, MSCHAP version 1 and MSCHAP version 2. So MSCHAP version 1 is a one-way authentication method is which the server requires authentication from the server. The version should not be used. So version 2, MSCHAP version 2 provides strong security because it uses a new string each time the authentication is challenged. In MSCHAP version 2, the client and server mutual authenticate and use 2 encryption keys, one for sending data and one for receiving data. Okay, so PEAP, CHAP and MSCHAP are authentication protocol intended for use primarily by hosts and routers that connect to a PPP point-to-point protocol or PPOE network server through switched circuit or dial-up lines. These are all older, less secure protocol. So in August 2012, so Microsoft advised against using MSCHAP version 2 and recommended using either MSCHAP with protocol extensible authentication protocol or more secure alternatives such as L2TP IPsec. So when implementing security for legacy protocol such as MSCHAP version 2 extension authentication protocol EAP can be used. So EAP is a password based authentication frameworks. In these implementations, the client doesn't need to have a certificate, but the authentication server has one. Password from the client are sent using hashes to the authentication server. Okay, so in the environment allow for strong authentications methods. So PEAP can be used. PEAP act as a TLS SSL tunnel and protect the authentication traffic. A PEAP uses a certificate on the authentication server and optionally a certificate on the client. Okay, let's move on the next slide. NTLM. So this is a like a directory service protocol, like a, what do you call, NTLM. LAN Manager is an older Microsoft authentication protocol that requires Active Directory and relies on Microsoft Word's user credential in the authentication process. NTLM was replaced with the Kerberos, starting with Windows 2000. NTLM authentication is similar to CHAP and MSCHAP. In the authentication is validated by means of random challenge generated by the server. NTLM also differs from CHAP and MSCHAP because it is specific to a Microsoft network environment as opposed to data link layer connections. So it's considered the NTLM authentication steps, or there are 5 important steps. The client send the username to server. In the picture you can also see that. And then a server generated challenge to return to the client, and then using the user password, the client encrypts the challenge and sends a response to server. For local accounts, the server validates the user's response based on the information in the security account manager. Okay, and then 5th one is for domain user account, the server forwards the response to your domain controller from validating of the user account based on the group policy. Then the server create an access token, establish a session. Okay. NTLM is easily exploitable and puts organization at risk for breach. All NTLM version uses a related, so it's relatively weak cryptographic scheme. So because a user must respond to a challenge from the target to authenticate to a machine, the password is exposed to offline cracking. Because NTLM is password based, it lacks effective support for multi-factor authentication solutions and is subject to reply and man-in-middle attack. Microsoft Guide to Restricting NTLM recommends first auditing all NTLM traffic and then conducting an analysis on server and users that are using NTLM. NTLM authentication could potentially be eliminated using options that are not necessarily organizations driven. For example, the organization might be required to conform to current regulations such as Sarbanes-Oxley that require the use of strong authentication mechanism than NTLM. To avoid sending the open plain text logon information across the unsecured network, one solution is systematic key authentication protocol known as Kerberos, created by Athena project at MIT and named for the three-handed dog Cerberus and guarded heads. Kerberos is authentication that has around for decades and is an open stand. Symmetric keys means that both the client and server must agree to use single key in the encryption and decryption process. Okay. Federated service. So the federated services, the technology used for federated identity includes a security assertion markup language, SAML, you can call it like that. Okay, and then OAuth, OpenID, simple web token, and JSON web token. So these technology use secure tokens. Token authentication is a better approach to authentication because it is stateless. Instead of authentications with the username and password for each resource, the user authentications once with the user and password and then receive a secure token. The token is then used for further authentications and expires after a set amount of time. This method prevents storage of user information on the server or sessions. So let's say using token provides restrictive permissions to third-party applications such as Twitter and Facebook. First we see the security assertions markup language. Okay, so security assertions markup language is a extensible markup language, XML in short. So XML framework for creating and exchanging security information between online partners. It is a product of the OASIS Security Services Technical Committee. Most cloud and software as a service software as a service provides favor SAML, the security assertion markup language, because it provides authentication assertions, attributes, assertions, and authorizations assertions. Authentications assertions validate the user identity. Attributes assertions contains information about the users, and authorization assertions identifies what the users is authorized to do. So the main purpose of SAML is a single sign-on for enterprise users. So the SAML framework defines three main functions. The user seeking to verify its identity is the principal. The entity that can verify the identity of the end user is the identity provider. Third is the entity that uses the identity provider to verify the identity of the end user is the service provider. So we will move to the next slide. So that's it for SAML. Open authorization. Open authorizations is a framework used for internet token based authorizations. The main purpose of open authorization is API authorization between applications. Two versions are used. The most current version, is version 2.0. So the open authorization framework consists of the three important things. The one is a resource owner, and the second is a open authorization provider, which is the hosting resource server. Third is the open authorization consumer, which is the resource consumer. So open authorization version 2.0 define 4 rules: resource owner, authorization server, resource owner, authorization server, resource server, and client. It creates separate rules for the resource servers and authorization servers. So Open Authorization 2.0 obtain authorizations by the users via an access tokens and then uses the token to make users request. Flows are ways to get an access token. Okay. You can also Google it to find more information about these open authorizations. Okay, let's move on the next slide. OpenID and OpenID Connect. So OpenID is an identity layer based on the Open Authorization 2.0 specific, used for consumer single sign-on. OpenID Connect implements authentication as an extension to the Open Authorization 2.0 authorizations process. Provide additional security, signing, encryptions of identity, data, and sessions management. So OpenID Connect is identity layer based on Open Authorization 2.0 specifications that is used for consumer single sign-on. So OpenID Connect is similar to Open Standard OpenID, sponsored by Facebook, Microsoft, Google, PayPal, Ping Identity System, Symantec, and Yahoo. So in 2015, Google recommended switching from OpenID to OpenConnect. OpenID Connect implements authentications as an extension to Open Authorizations 2.0 and provides additional mechanism for signing, encryptions of identity, data, and session management. Okay, so the OpenID Connect protocol specifies guide states this process for validating there are 5 important things. So one is the client sends a request to OpenID provider. So you can also see the picture. The client sends a request to the OpenID provider, and the second is the authenticates the end users and obtain the authorization. The third is the OpenID provider responds with an ID token and an access token. The client sends a request with the access token to the user info endpoint. Then the last one, the user info endpoint returns the claims about the end user. So this is the best example, the picture. So the OpenID Connect uses an ID token structure that contains an authorization server's claims about the authentication of end users through a JSON web tokens. So a JWT is used to prove that the sent data was created by an authenticate source. The flow determines how the ID token and access token are returned to the client. Authentication takes place through one of the three flow. One is an authorization code flow, return an authorization code to the client which then exchange it for ID token and access token. And the second is the implicit flow, eliminate the token endpoint. All tokens are returned from the authorization endpoint. And third is the hybrid flow, can have some token returned from the authorizations endpoint and some returned from the token endpoint. So the OpenID Connect specification takes attacks into considerations and resolve many of the security issue with the the open authorization 2.0. However, if guidelines are not followed to implement it, securely broken end user authentications can result. Okay, so let's move on the next slide. Exam preparations. This access control protocol for use on network uses UDP transport to send authentication information to central server. Answer D. Radius. Answer is Radius. Second one, this protocol uses a key distribution center to orchestrate the authentication process. Answer C. Kerberos. Answer is Kerberos. So that's it guys for this video. Please subscribe my channel, press the bell button to get more update, share the video if you like. Have a good day guys. We will see the practice lab. The practice lab is the next video. I will post the next video, practice lab, so you guys also watch my practice lab, so it is very useful guys to understand. Okay, see you, bye bye, have a good day.